Optimize Python for better performance. Optimizing Python code for better performance is essential for building efficient and scalable applications. There are several techniques that can be used to improve the runtime speed and reduce memory usage of Python code. One technique is to use built-in Python libraries that are optimized for performance. For example, the NumberPy library is commonly used for numerical computations, and is known to be faster than using Python's built-in mathematical functions. Similarly, the pandas library is often used for data manipulation and is known to be faster than using Python's built-in data structures. Another technique is to use profiling tools such as cprofile and line_profiler to identify performance bottlenecks in your code. These tools can help you understand which parts of your code are taking the most time to execute and where memory is being used excessively. Reducing unnecessary loops and using built-in functions is also a good way to optimize your code. Instead of using for loops for iterating over a list, you can use list comprehension, which is faster. Also, using built-in functions like map, filter, and reduce can also help to reduce the number of lines of code and improve performance. Cython is a Python library that can be used to speed up Python code by converting it to C. Cython can be used to optimize computationally intensive parts of Python code, such as numerical computations. Parallelization and concurrency can also help to improve the performance of Python code. Python's multiprocessing library can be used to run code in parallel across multiple CPU cores. Python's threading library can be used to run code concurrently within a single process. It's also important to note that it's not always necessary to optimize your code. It's worth to measure the performance of your code before and after optimization. And optimize only the parts of your code that are causing performance issues. In summary, optimizing Python code for better performance involves techniques such as using built-in libraries, profiling tools, reducing unnecessary loops, using built-in functions, and using libraries like Cython. Additionally, using concurrency and parallelization can also help in improving the performance of the code. It's important to follow best practices like writing efficient code and avoiding common performance pitfalls in Python to achieve better performance.